Hello everyone. As we know that Environment Protection Training and Research Institute presents a grand challenge for innovative ideas. Their proposal is for effective dryer system for unsegregated municipal solid waste. We, Shweta, Meghana, and Amrutavalli are presenting a solution on their proposal. So we are from Mahindra University. Studying in computer aided structural engineering in civil engineering department. So the topic is effective dryer system for unsegregated municipal solid waste. These are the contents: problem statement, proposed solution, process, components, thermal dryer room, and special precautions to be taken. The problem statement is GHMC is generating about 8,000 tons per day of unsegregated waste. It is being collected, transported, and scientifically processed and disposed by Hyderabad Integrated Municipal Solid Waste Limited at Jawahar Nagar Integrated Facility. The objectives are to design a prototype model for drying unsegregated municipal solid waste coming from tipping floor, to reduce the moisture content so that the next process becomes faster and easier. So here the main aim is to design high capacity, minimum 800 tons per hour dryer, to reduce the offensive odor and accumulation of large waste, and to design a sustainable and cost friendly dryer. This is the proposed solution. The dryer is being segregated here, has the same mechanism as a thermal air dryer, but it has a larger capacity. Unsegregated municipal solid waste can utilize this dryer to lose up to 80% of their moisture content and 75% of their weight. This dryer has a capacity of 800 tons per hour. This dryer is economical, eco-friendly, and known as zero energy dryer. After drying, the gas produced by municipal solid waste can also be recycled without being released into the atmosphere. This dryer can dry 7,000 to 8,000 tons of municipal solid waste per day. So, by using this dryer, we can avoid the major problem like resulting in accumulation of the waste of the tipping floor and creating order manner. This is the process. First, gas engine generator. So here we can use natural gas engine generator, either CNG or RNG. So in gas engine generator, hot exhaust gas is released. That hot exhaust gas is sent to the mixer and air heater. From mixer and air heater, the gas is again sent into the dryer in three stages. First stage is thermophilic heating, second stage thermophilic evaporation, third stage forced evaporation. So from dryer, the gas which is released from the municipal solid waste is sent to the gasifier. From gasifier, the gas is again sent to the gas engine generator. So it is total a recycle process. So from the gas which is sent from the gasifier to the gas engine generator can be utilized to produce electricity also. Here, after completion of coal process, the municipal solid waste which is discharged at the outlet, at that time we on the high capacity heater, so that if there is any moisture content, that is also removed. And these are the components of the system: thermal dryer room, gasifier, engine or gas generator, mixer and air heater, high capacity heater, pipes or conduits. And this is the engine, gas engine generator, mixer and air heater, again dryer, gasifier, the high heat capacity heater, inlet and outlet pipes, air pipes.
So talking about the thermal dryer room, municipal solid waste which is fed into the dryer chamber, and the gas engine generator is what that creates the hot exhaust gas. The gas engine generator sends the gas to the mixer. Additionally, ambient air is sent to the mixer. In three phases, the hot gas and the air are combined and transferred into the dryer room. We can see this mechanism by playing this video. The first stage is thermophilic heating. It is the initial stage of heating of the for heat to circulate into the dryer partially and heat the dryer. And in thermophilic heating, we will send the mixed air of temperature 110 degrees Celsius. In this process, 20% of moisture is removed and 10% of municipal solid waste is reduced. The duration is approximately 10 to 15 minutes. As we can see, the heat is getting more temperature in the video. Next, it is the second stage, which is thermophilic evaporation. In this stage, the heat from the hot air starts evaporating and the water or the moisture content present in the waste and converting into vapors. By increasing the temperature, the vapor pressure increased, resulting in high rate of evaporation. In thermophilic evaporation, we will be sending a temperature of 160 degrees Celsius. And in this process, 55% of moisture is removed and 40% of municipal solid waste weight is reduced. And this duration is approximately 30 to 45 minutes. Next stage is forced air heat evaporation. This is the final stage and highly moist particles are targeted to dry in this process, and the temperature sent here is 230 to 240 degrees Celsius. Here 80% of the moisture is removed and 75% of the municipal solid waste is reduced, and this duration is approximately 10 to 15 minutes. Next, this is the design of the drying room. And in this design, we have considered the density of the municipal solid waste to be 600 kg per meter cube according to the Creed Working Papers Index. By doing calculations, we obtained the length and breadth to be 30 into 20 meters, and the height which we considered is 2.5 meters. The height which we considered is very less because the air can easily circulate in the room. Next, this is the top view of the air dryer, and we can see the air heater. From air heater, we are having the main air pipes, which are diameter of 40 mm, and the sub air pipes are of 25 mm. And according to the dimensions, we have spaced this, and we also provided the stoppers, which are of 25 mm diameter and with spacing 2 meters. So next, gas engine generator. The gas engine generator used here is natural gas engine generator. A natural gas generator is like that runs on natural gas instead of typical choices like gasoline or diesel, which are very non-renewable sources of energy. So here we can even use CNG or RNG. RNG is actually available in abundant, and it is very eco-friendly. Mixer and air heater. The air from air heater in the mixer is mixed with the gas generated from the gas engine generator to produce high heat air gas mixture into the dryer for drying. The temperature can be controlled as per the requirements as the heat is generated from the electric air heater. The air heater here used is electrical air duct heater, which is having high temperature capacity of 200 to 800 degrees Celsius. This air heater is inexpensive, compact in size, and highly efficient and used for drying at high temperatures. And the speed of the air here is 10 degrees Celsius per second. For being eco-friendly, the air heater can even be run with the solar electricity for low power consumption. Next, gasifier. This is which collects the gas from the generator from the municipal solid waste after drying in the drying room. The gas collected is sent to gas engine generator, and it is recycled, or again it is sent to the air heater and mixer. We can also produce even electricity from the gas which is collected from the gasifier. Pipes and stoppers, and here the air connection pipes and holes are used in overall process is 25 mm dia. The stoppers are of 25 dia. Why we are using stoppers? Because to release the air into the dryer and from the pipes carrying thermal flow. And the stoppers will circulate the dry air in the uniform flow and will prevent the pipe to get damaged from the waste particles to enter into the air pipe. High heat capacity heater. This is provided at the end of the dryer at the start of the outlet of the dried municipal solid waste. After the three-stage process of drying, the high capacity heater is switched on for limited time during the disposal of the dried waste from the outlet pipe. The waste is ensured to pass through this hot air heater so that the particles in the case which are not drying during the process can be dried and the moisture content can be reduced. And these are the special precautions which can be taken to prevent the air blocking. If there is a chance of blockage of air in the stoppers by the municipal solid waste, we are proposing to provide very fine size holes to the stoppers so that the particles will not enter the air pipes and avoid the blockage of air. To prevent air escaping, if there is a chance of any air escaping from the drying room, then we will not be having a effective drying. So to avoid this problem, we are proposing very strong locking systems. To prevent damage of the pipes, we are sending hot gas and hot air through the air pipelines. So there is a chance of damage of the pipes due to high heat. So we are proposing an insulated air pipes. This is our system. Thank you.